I was working in a QR code solution uh, 3 years ago. It was written in C, and so this is that uh, piece of software, and all of the commits here is mine from the beginning. So I was in the process of doing it, became intimately familiar of the QR code technology. And one thing I can say is that although it might seem simple, as you can just open a browser and generate a QR code. The QR code generation is one of the is a very complex one. It has a lot of mathematics and low-level code in it. So this one is an encrypted QR code, which is locked. And when you scan it through a scanner, it needed the face of the owner to decrypt. So if a different person is carrying the QR code, then you cannot read its content. It will just be garbage. So again, if a different person aside from the intended owner is carrying this, then it will not unlock. Once it unlocks because of face and biometrics, then it will display arbitrary information inside the QR code. In the example here, we encoded the birthday, the sex, the gender, and so on. So these pieces of information will be presented upon unlocking. Now this is written in C and then wrapped in C++ and then wrapped in Java. But one of the and I was doing this under this organization that time, which was heavily focused on identity solutions, wherein I was involved in the necessary pieces of technology for to have identity solutions. One of it is cryptography, then the other is mobile development in Java and C. Now, moving forward, because of that job, I examined the entire terrain of QR code for many, many months and year, and maybe up to a year. And so I can say that uh, I am very familiar with the possible QR code generator that is available there, especially the open source version. This one by Nayuki is one of the best. So today, moving forward, I took the time to clone this repository which I use as a reference while I was learning how to do it. And then using the static analyzer tool from Parasoft, I subjected the code base through static analysis. Static analysis is a method of gaining a very fast insight of a huge C++ code with the intention of discovering defects and code improvements. This is very useful, especially in the fast-growing C++ landscape now. The tool consists of 5,000 static analysis rules here. There are 5,008 in total. Uh, Rules like having to do with threads or mutex, this type here, and you can see uh, what they are. So do not call lock directly on a mutex. So you can right click here and then you can view documentation about this particular rule, an example, defective construction, and the repair. So, like I said, any C++ developer nowadays can immediately understand the enormous value of this static analyzer. The evolution of C++ has reached to a point where it is very hard to make sense of these new constructions. Now, let us try to analyze this code with through static analysis. So you right click, you do a test using built-in static analysis, and let me try a flow analysis. The intention of static analysis is to discover defects without producing a binary. So it just scans through the code in its alphabetic form, uh, and then will attempt to find probable issues with it, like memory allocation and so on. Here it found one issue, and the issue is division by total may possibly be zero. If you double click there, you will be pointed to the place where this possible uh, problem might occur. Hmm. I don't know what this is. No, this is like what Forrest Gump said. You've been presented with the box of chocolate and you don't know what you got. So, but at least through pattern recognition and static analysis, we can now stare into these blocks of code and review this. Amazing. And then you can right click particular findings, view documentation again, and like I said, the literature of these issues now described. Yeah, it can also become a rich set of reference as well. We will delete this and let's try to scan again through a different rule. Test using static analysis and modern C++, the dragon. So let's try. Even if you master C, um, in the face of modern C++, all of this mastery is not going to be uh, um, useful as you know modern C++ is now very different. The semantics of programming in modern C++ has changed. Although it's still compatible to C, but object-oriented in modern C++ is needs getting used to. Again, that is the findings there. Not only it can do static analysis, it can also generate test cases. If you have used Google Test, you have tried how tedious it is to, because before you can construct a test cases, first you have to know what are the objects. Then you instantiate the objects with expected parameters, call methods, and make assertions, meaning you have to understand that certain values have to have a particular value in order to assert it, right? But here, we do not understand the code, but it can generate these cases immediately. So go to Parasoft, this using built-in unit testing and generate unit test. So the output of this is just like a Google test cases. At least it will give us the skeleton, but of course it is still subject to human intervention as as I will show you when this generation will complete. The assertion that is auto-generated here is not an assertion. It's a printf statement. And then a human developer has to manually verify the outcome, and it will be converted into an assertion. So let's see. So one function has 10 or 20 these cases. Okay. So for example, this one is a synthesize this case. So this is auto-generated. It understood this data type. It understood this initialization. It invokes certain calls, and then it synthesizes assertions. These are the post condition. These are the assertions it was trying to in a form of printf message. If you if we run this later on, it will print a value, and if the value is acceptable or correct, then we right click one more time, and this will become an assert statement. Okay, so like so these are synthesized. Of course, you can continue to modify this piece of code here. You can continue to add more as you see fit. So it, that's the idea. Now, going back to the code base, and let's try to review the various compliance that it offers. In the aerospace, we have the DO178C. Uh, we have in the automotive, we have the AutoSAR, the 26262, the Mesra from 1998 up to the latest 2023. And the medical devices, we have FDA. In security pack, we have a very robust CWE collection of rules. And embedded systems, we support integration to ARM here, Green Hills, Kiel, Chemo, QNX, Qualcomm, Renesas, Texas Instrument. So while what I'm demoing here is the built-in IDE, our Parasoft tool can't integrate into your Eclipse-based IDE. So if you have Texas Instruments Eclipse-based IDE, you can add the plugin, and this dialog here will be made available into your whatever IDE you're using. And what else? So my first impression of this tool is that it has a nostalgic old guys feeling to it. It looks old. It looks it does not look modern. It has an old touch. Because you can see the things that is listing here are some of them are no longer with us, but you can understand where if you've been here, so you have seen these things, and it's still here. So, like I said, it has a touch of being old, but it fits the bill because C and C plus C is old, and so this guy has been there. This tool has been there, battle tested, and it does not try to look modern and fancy. So this is a tool for hardcore C and C++ static analysis. Despite its heritage is old, but it does have uh, continuous update to modern C++ standards. So what needs to happen if you purchase this tool is you will be given a license here, and so it is a machine-based license. Once you have the license, you can scan any code to your heart's content. There's no limit. There's no limit to the number of lines. In fact, I scanned the entire Linux kernel using this tool, and I saw um, the reports that it generated in different drivers and subsystems. And of course, there's a lot of findings there from buffer overflow and so on. Of course, subject to further investigation and whether they're true or not. But static analysis is 99%, but that's 100% correct. They are just trying to help us. And yeah, it can scan big code base. You can use it to scan as many times as you want. There's no limit. I know that other tools puts a limit to the number of scans that you can do. Our tool also has integration to GitHub and GitLab. So while this tool here is GUI based, trust me when I tell you, I breathe in and live in the command line. The tool is fully operational in the command line. Okay, everything you can do in IDE, you can do in the command line. So its manifestation in the command line, it will produce an XML static analysis report interface format or SAREP, and then uploads to GitHub for static analysis. Like you can see, I think I have it here. GitHub, uh, direct demo CI/CD. So what I'm trying to say is you have your code in GitHub, and then your analysis will be projects. Where is it? Uh, Code scan, issues, actions, security, insights. How about test runs? Let me try demo CI/CD 2. I think I have it in the 2. I was looking for a static analysis report and visualize in CI/CD of GitHub. Let me see. I think it was on a branch that I deleted. Well, to simplify this, eventually it boils down to a YAML file. So if you look into the YAML, you can see that at the back end of the runner, you run the CLI command of the analyzer, fully operational in the command line, and then it will generate a report XML. The report XML is submitted to GitHub, and then GitHub will visualize the code static analysis. So it's an automated CI/CD uh, way of working. Uh, of course, the IDE way of working is also tailored to assist the developer as he he's in his code. You can use VS Code. I believe that if you have vim command, you can also use it, and you can use the inotify to watch the file system, and anytime the file changes, invoke static analysis. We also support Visual Studio 2022, so for Windows programming. And we have a variant of this tool in Java, but it's a different product. This one is only for C++. So if you want the Java version, you have to purchase the JTest product.